All right, so welcome everyone to the Java Autograding webinar, and I'll be going over everything you need to know about autograding Java and also a little bit about manually grading Java in CodeGrade. It will be kind of similar to what we've done with Python before, but of course there's no Jupyter notebooks for Java, so I've decided to go into the code quality step a little bit more in depth. So the schedule will be that first I'll go over some basic auto grading and manual grading Java tips and tricks from a very easy intro to Java example course assignment to setting up your handling requirements. So both your manual and your automatic grading becomes easier, to how to compile Java code in CodeGrade and setting up some easy IO tests. So with these tools, you'll be able to set up really easy Java assignments in CodeGrade and have them auto-graded. Then after that, I would like to go into the code quality step a little bit more in depth. We actually have two separate Java linters available, that is Checkstyle and PMD. And I think it's a great opportunity to go over what both of them can do for you, what the differences are between them, and then after that go in depth on how you can set up your own custom style guides for both of them and really get the most out of them. And I think they're really powerful tools, and with the tips I'll be giving you, it will be really easy for you to use them in a very meaningful way for education as well. So that's pretty cool. And finally, I'll really quickly show the unit testing. We've covered that already before, but I'll show you that. And then finally, I'll show you how you can use JaCoCo, which is Java code coverage, to assess unit tests that your students hand in. I've discussed this also in a blog before, so I'll not be going in depth on this, just showing you what's possible. And then if you want to replicate that, you can read the blog and you'll be able to copy all the code from there. Same goes for the semgrep one. I also talked about that in the Python webinar, and I have a separate blog about that one, just going over what's possible for Java, and you can find all the example codes and all the further explanation of that in our blog. So let's get started with the basic assignment. And I think always a nice example is a Fibonacci assignment for an introduction to Java programming course. And in this case, we have a really basic assignment with two rubric categories. One is just checking if running Fibonacci.java works. So given an input, does it give us the right output? And the second one is a bonus where we say that if we give a 0 as input, it doesn't crash. Since, of course, a list of 0, it's possible, but it could crash the program. So we check that as well. And let me show you how that works. You can see my Canvas screen right now, right, Yuri? Good. All right, thanks. So let me go to the Java assignment that I've set up here. And again, just a very easy example usage here. You give an input, a number, and the Fibonacci sequence that you return will be with the number of items as you have set in the input. So let me go to the assignment here and upload the files. Again, the rubric can be seen here, pretty easy. Upload the files, and what's nice, right away we see the handling requirements. We know that we have to hand in Fibonacci.java, and we are required to do that, and we're not allowed to hand in anything else. This is just one example of what's possible, and I'll be going over some other possibilities as well later on. So let me upload that, open submit, and the auto test will start running. As you can see, there's very easy input-output tests here. So we just say Java Fibonacci 1, and then we expect the output to be 0. And then here, 15, we expect a Fibonacci sequence of 15 items. And then for the bonus, of course, we try to give a non-digit input, so a word, and we give a 0. All right, so this should be running right now. And there we go. So as we can see here, the outputs are as expected, and we got a full grade, and everything is automatically graded. So we can see that we got a 10 out of 10 for this one, 100%. We can see the code here. So this is just a very easy example of a Java auto-graded assignment in CodeGrade. From the student perspective, of course, just so you get a feeling of what that looks like. And now, of course, we can start setting one up ourselves. That's more exciting. So let's start with some basics, and maybe this is easy for some of you, but it's a good refresher, I think. Handling requirements are pretty important for any assignment, but I think especially for Java assignments, for the reason that in Java, you often have a lot more files that you work with, and also the folder and the directory structure is more important in Java than in some other programming languages. And depending on your assignment, there could be multiple tactics you can use handling requirements for to get the desired folder structure of the student. And of course, they can hand in archives in CodeGrade. They'll be extracted automatically, and that will work with the handling requirements as well. So the one that you just saw with Fibonacci is this most straightforward one, is where we just require the different Java files that we need. And as you can see, they're all with this folder here. And that means that it's the root of the submission. So we expect that all of these are in the root of the submission or in like the first folder that the student hands in. And all the other files are denied. Then another one that we can use is this one, where we allow all files, but deny certain other files. In this case, we say we allow all files, we require hello world.java, and we allow any other Java file, but we deny any class files. So anything that ends with .class, we deny. And how you can do that is by using a wildcard. As you can see, it's called anything here. And you can just use a star icon .class, and that will result in a wildcard. So that's also a possibility, of course, if you want to allow some more flexibility to your students. Finally, another one is by really giving the full folder structure that your student have to use. So an example is source, com, CodeGrade, class 1. And as you can see here, we have these different folders in which class 1 should be. So for our assignment that we're going to be setting up, I'll be replicating this one since it's a really closed assignment. So let's scroll down to our handler requirements here. We say we deny all files, and we can set up the rules. So we want a sudoku solver.java. We want a cell.java. And we want a, we check which one else. We want a board.java. So as you can see, I'm putting this / here in front of the file names. And that means that I want this to be in the root directory. And that's also why this icon is here. Now let me allow a report. And if I do not use this / here, because I don't care where they upload this report, as I'm not auto-grading it, as you can see now, you will have this anywhere here. So it can be anywhere in the submission. Now, one more thing I want to show you is the delete leading directories. And as we can see in the slides, in this submission, the students will have leading directories, source, com, and CodeGrade. And all the files that they hand in are in those directories. But of course, for Java to run, these directories have to be present, since this is the whole package. And if you turn on delete leading directories, these directories will be deleted since they're leading and all the files are in the same leading directories. So if you do not want that to happen, simply press disable here and these will not be deleted automatically. For most submission or assignments, of course, it is desirable to leave this on since that will clean up all the submissions. But for these Java assignments and maybe other programming languages as well, where the folder hierarchy is important, you can turn this off. So let me submit this now. And we have set up our handler requirements. And I think for the next step, we can start creating our auto grader with auto test. So another thing that is a little bit more complicated with Java than, for instance, with the Python one, is that Java is, of course, a compiled programming language. So we have to compile the student code somewhere in our auto test. And there's kind of two ways you can do that in CodeGrade Auto Test, and both have their benefits. and it's kind of up to you what you prefer. So you can compile the student code in the per student setup script. So that is in the configuration of the auto test. And what that means is that it is available to all the categories and all the steps that come behind it. And you only have to compile the student code one time for the entire auto test. The downside of this is that it is not graded. So it can be that it doesn't compile, but there's no grade to it. Of course, all the other tests will fail as well since there's no compiled files. But if you want to have a separate grade for this, then you can do it in a run program step. So this means that you can put a grade to it. You can connect it to a rubric category, especially for introductory courses. Only the compilation step is already worth some points, I think. But the downside, of course, by not doing it in the per student setup script is that it is only available in the current category that you have the run program step in, and you have to compile it for each category that you want to run student code with. So these are the two options, and for the example I'm doing right now, I'll just be using the per student setup script to make it a little bit easier. So let's go to auto test and create an auto test. And I've already set up a rubric here. Of course, you have to do that before auto test. Actually, I imported it. And for our Java assignment, let's simply compile it right here. And I'll just use the start.java. So I compile all the Java files that the student has handed in here. Probably this is known to you. All right, so now what I can do is I can add my levels, add my categories, and I can use these compiled Java files. And for that, let's create some simple input-output tests, the most basic one. And since this is a Java Sudoku solver, what we want is we want to give a Sudoku in this format. So all the empty cells will be an underscore. And we want the Java program that the student has written to have a output of the solution like this. And we do this by the standard input. So we write this in the program and this via the standard output, of course, which is just the system.out. All right, so let's create this and set this up. So let's add a category, select the rubric category for this, in this case, the functionality. And we can create our IO test, give it a name, check Sudoku. Such a hard word, Sudoku solutions. And we can run the Sudoku solver. And this is available since we already compiled it in the per student setup script before this. And let's do a 9x9 easy. And now let me copy and paste some of these Sudoku inputs and outputs. So in this case, we want this as the input, which is just a 9x9 grid with these underscores. And then the expected output is this. And since we do not really care about the white space, let's set the ignore all white space on. And we can add another input. And let's make this 9x9 hard. And again, I will copy and paste a Sudoku input. And I'll copy and paste a Sudoku output right here. So this is really all there is to it. We can now save this and run this, and we can see that once we run this, it will check the student code for these inputs and outputs. So with just these two steps, first compiling the student code in the per student setup script, and then making some of these input and output steps, it is really easy to have some auto grading already. And with just this, you can already automate your workflow that you may have with manual grading, where you would also do these steps and then maybe run the student code with some input and output manually. You can just port that, put it in your input and output steps in your CodeGrade auto test, and now every time a student hands in, this will run automatically. And as we can see right here as well, right away, we see that it worked. So it gave the expected output that we require. Great. So this is just a really basic, easy assignment, and you can create more of these as much as you want, basically. So before I go on to the code quality step, Yuri, I saw there is some questions. Anything you want to share?
I think it's pretty clear in the chat, but it's maybe where you want to do the compiling. So you can do it in the persistent setup script, and then afterwards in the run program, you can check if the .class files exist. That's also something Paul was highlighting.
Yes, that's really.
But then, well, I would just read the message from Paul in the chat.
All right.
You get the gist of it.
All right, good. All right, so let's go on with the code quality steps. So next to the I/O test step in CodeGrade, you also have the code quality step, and for different languages, we have different ways of grading. And what that results to is that after this runs, it will automatically assess the style of the code, and next to giving a grade and fitting in a rubric, it will also give these inline comments to it. So as you can see, errors are highlighted, and you can see the message in the code as well. So here the ampersand should be on a new line, and here you should avoid unused local variables such as temp. And this makes it really easy for the student and really useful. Now for Java, we have actually two different types of linters that you can use for your code quality steps, and they are Checkstyle and PMD. Let me start with Checkstyle. That is more of a traditional linter. It's a static code analysis tool for Java, and it checks the presentation or the style of the code and checks whether that is conform to a style guide that you have set up. It does not confirm the correctness or completeness or errors in the code. It really is just a style checker. Which is also why the name is probably called Checkstyle. So it detects, among other things, the documentation, if there's Java docs used, your naming conventions, use of white space, vertical and horizontal, and also conventions for parameters, headers, and imports that you've set up. Next to that, we also have PMD, which is, well, it's unknown what this stands for, but one of the suggestions is that it stands for Programming Mistake Detector, which is also kind of what it is. So it detects common programming mistakes in your Java code. Not only your Java code, it also works on JavaScript and XML, for instance, and some other lesser known languages. But these are the ones that we see most commonly used in CodeGrade. So this doesn't just detect the style, it checks the bad coding practices. And those are, amongst other things, inefficient code, bad programming habits, overcomplicated expressions, things that should be simplified, potential bugs, dead code, and duplicate code, since there's also a CPD included. So these are the two options you have. And of course, you can also add your own linter in there, your own tools. But these are the ones that we support right out the box. And I think these are really powerful and highly customizable to be used in education. And I'll be going over both of them in the upcoming slides. So let's start with Checkstyle. So Checkstyle is set up like this. So you select Checkstyle as your linter in your code quality step, and then you have to set up a configuration file. And this is where you define your style guide. And I'll be going over what that is in a second. Next to the configuration file, you can, of course, give extra arguments, and you can set the penalties for the different message levels or the severity levels of the messages. And if you want, you can put these all to 0, and this will not be graded, but it will only be an indication to the student, a helpful indication. But you can also set up penalties for these different levels of penalties. So for this configuration file, there's kind of two things you can do. Either you can manually create one, or you can download and use a default style guide, like the Google style guide or the Sun style guide, and enforce that in your class. So maybe to start off, it's good to discuss kind of why code style is important. Of course, it's important for students to learn how to use a style guide in general, since that will be maybe not so important for their individual code projects, but especially in their later career, or if they will do group projects or work together on code, it will be impossible to do that without a style guide. Next to that, it's also important to immediately, and then we are talking about introductory courses, start learning code with a solid style and conventions. I remember that when I started, I already did some YouTube tutorials and things like that before I started my university education, and I had really bad programming practices. And because you don't learn them in your YouTube tutorials. And the first couple of assignments were pretty hard for me because all I was doing is just getting rid of those previous bad programming practices. So it is good to start with a solid basis in this. Now, you can define the style guide for your class, and this can be consisting of rules that you think are important. So it can be kind of in two ways. You can either download one of these, the Google or the Sun style guide, and then strip out the rules that you don't want to use, or add rules. But you can also set up your own style guide, and that can consist of just a couple rules that you find important, or it can be really big. And I have set up a couple of them in the next slide that I think are very useful for education, and they just give you an idea of what you can do with Checkstyle. So a style guide in Checkstyle kind of looks like this. It's a very easy XML file, and this is one I just downloaded from Sun, as you can see here. And in the module, you'll have different properties and you'll have different modules, or in the checker module, I have to say. And in this checker module, you'll have all these modules for your different checks. For instance, here I have a module with the name modifier order, which is a check to check if the modifiers are in the correct order. Then we have a module here that is a redundant modifier, which checks if there is modifiers like public or private or final that are redundant. And as you can see, this module right here, this is check, I've given properties to make it more custom. So what I've done, for instance, here is give it a severity level, and I've given it a custom message to make it more applicable to my students. So this is what it looks like. And these are some individual tests that I think are useful. So what I've done for you is I've went through all the tests that are available in Checkstyle, and I've distilled a couple that I think are good for education, but this is by no means an exhaustive list. So let me just go over them. So first of all, the file tab character, I think it speaks for itself that most teachers enforce the students to use spaces instead of tabs. And with this check, you check if there's no tab characters in the file. Next to that, indentation also speaks for itself. It checks if the indentation is correct. We changed a property here for the case indentation, which is a recommendation from the Oracle style guide. Next to that, the constant name. So now we'll talk about a couple of naming conventions. So as you know, in Java, the naming convention for a constant is all capitals and snake case. So like this, first constant. And using this, you enforce the students to use this naming convention in their file. Then after that, we have some naming conventions for the variables and the parameters and the methods. And of course, these should be lower camel case in Java. So these different modules check that. And I think these are really important to learn the students these naming conventions, since they are pretty universal across Oracle, Google, Sun, all those style guides. Now, after that, we have the line length, of course, which is a very common one where we check the length of the lines. Now, Oracle recommends 80 characters per line. I remember being taught using 120 characters per line, which I think is a little bit more sensible for Java. But again, you can just specify this in the property with the name max right here. Then we have one that checks whether there's no star import used, since that is a bad practice. Then also one that has a white space check. So instead of using method foo, comma bar with no white space, you of course want a space between foo and bar. Need braces, enforced use of braces around code blocks. This is a personal choice as well. For instance, in Java, you can have those one-liners, one-liner if statements, and you can do them without braces. And it's a good practice to always use braces around them since it introduces bugs if you have a one-liner like that and you want to make it a little bit longer and then you forget your braces. Finally, a magic number. This is something that is, I think, you come across it in every introductory course. Magic number should be documented, and with this check, you check that there's no magic numbers that are undocumented in the file. They should all be constants. And this is excluding -1, 0, 1, and 2, which are not considered magic numbers. So that is Checkstyle. And again, I went through this very quickly, but I think it's good for you to get an overview of what's possible with it, so you can make your own style guide and make the most out of that. Of course, you can rewatch this in the YouTube video, and I'll be publishing a blog about this later with some more detail. So now let's go to PMD. The setup is the same. You select the linter, select your configuration file, and you set up your penalties. Now, again, you can download a common configuration file of, for instance, Apache's Mavens, but you can also manually select your rules again. And PMD is useful since it automatically detects and grades bad practices in student code. And also, you can check expected bad practices with a short and specific rule configuration. So for instance, you can find common bad practices and mistakes for an object-oriented programming class or a multi-threading class or things like that. And they're all present and they're already available in PMD. You just have to select them. Finally, and this is something I won't go into in this webinar, but it's something you can look into if you like that. You can also create totally custom rules. And in that way, it can kind of work like semgrep in a way. And you can really well, find the things that you need to find. I think one thing to mention about PMD is that it is a little bit more advanced, I think, than Checkstyle. And many bad practices that it catches, especially if you use something like Maven, it will be too complicated for beginning programmers and it could be off-putting for them. So when you use this in introductory courses, be careful with the rules that you choose and make sure to customize your configuration file. And a configuration file looks like this. Again, a very simple XML file with a rule set, and each rule is defined right here. And again, there's a whole documentation with all these rules, and I've read through it, and I've distilled a couple that I want to share with you. So first of all, I think an important one is, especially for maybe data structures courses, is the check result set. So something that often creates bugs is that the return value of the method like .next or the previous method or those kind of methods in data structures are not checked, and that can, of course, inflict a bug. So this checks that all of these methods are checked. Then some straightforward ones: unused imports, checks that all of the imports that you have are actually used, and tells you about unused ones. This one checks that there are no variables, private methods, all of those things that are unused, since they're simply redundant code, and they should be deleted. Then right here, we check whether a for loop could be simplified to a while loop. I think that is applicable to many different types of courses. And here we check also if statements can be simplified. So if two if statements that are consecutive to each other can be combined to one if statement, since they check kind of the same thing. Then right here, we check if there is empty code blocks. For instance, a empty catch block or an empty while statement or things like that. And of course, that can be something you forget, and that can likely lead to a bug. Or if you leave it empty on purpose, it is often a bad coding practice. Finally, a couple ones that I think were interesting, but are a little bit more specific. The jumbled incrementer. This is one that is specifically there to find hard to find bugs. Where you have a for loop like this, and you use different types of variables inside your for loop. So right here, we initialize k, and we check if k is still underneath 20, but then right here, we increment I. So of course, this can be a never-ending loop, but on the first glance, this looks like a good for loop. Then right here checks if there's if statements that are always true or always false. Of course, that is a redundant if statement and it can be removed. And finally, this checks that if you have a string, that a dot equals function is used and not the equal or like a not equal like this, since that is not actually comparing the content of the strings, but merely the references of it. So this is one that is specifically useful, I think, for something like a object-oriented programming class. So now I've shown you a lot of these different rules and checks, but I think what is the most powerful of these tools is that you can customize them really well yourself. And you can do that by having a custom message and also by having custom severity levels. So these severity levels, again, if we go back to, for instance, this one, you can set up the penalties in CodeGrade for the different severity levels. And by changing them for your rules, you can, of course, say how much deduction there should be for a rule. So if we look here for PMD, and you can look this back in the video later on, you can use the message attribute to set a custom message. And I think with that, it makes it really powerful to explain to your students a little bit more why this is a problem for the class that they're having, and also on the level of the student, of course. I think maybe for more advanced courses, you can just leave the messages as is, but for introductory courses, especially if you only have a couple of rules that you've set up for them, it is really useful to give them more clear and more elaborate messages. And these messages will be visible in CodeGrade, of course. And again, the priority you can set based on these numbers. The same goes for Checkstyle, where you can have a message, and in Checkstyle, the message can be even more elaborate, since you can use placeholders as well, and these are all found in the documentation for each individual rule. And for the severity level in Checkstyle, you have the options between info, warning, and error. So there's no fatal in Checkstyle. Great. So I went over this really quickly, and probably it's hard to keep track, but I hope this gave you a good idea of what's possible with Checkstyle and PMD, and gives you some inspiration to start using these very effectively in your own classes. Before I continue, Yuri, anything you want to share with everyone?
So there is a question. What about Boolean functions where the value is returned as constant instead of so a function where you return a Boolean value as a constant? Do you know if there's a check for that?
In PMD, I think there is, yes.
Okay.
Yes.
I guess it would be digging through the docs for that.
Mm-hmm.
And then another question, I'll guess that it's really hard to detect for a simple lint rule. I don't quite understand what you mean with that.
So if maybe I'm interpreting it wrong.
Oh, that's the answer to Anders. No, never mind.
All right, great. So one thing I want to add is that please don't be outputted by all the different configurations I've shown you here. It is, of course, possible to use these linters with a standard configuration file. As I mentioned, just download that, paste it in CodeGrade, and then they will work and run out of the box. And most of the times, that is very sufficient and works really well as well. Just giving you these options so that if you feel like customizing them, or if you want to check really specific things, you have the tools to do that. So it's also possible without all of these things. So let me quickly go over Java unit testing. And this is very similar to all the other unit testing frameworks and the one I've shown you in the Python webinar. So that's why I'll be going over this a little bit more quickly. 4 steps: you upload your unit tests as fixtures and you move them to the student folder. Then you install CG JUnit 5. using JUnit 5 install in the global setup script. Then you compile the code and the tests. So that's the student code and the tests using the JUnit 5 compile. And then finally, you run them in the unit test tab using this command right here. And as you already announced, we will shortly be bringing out easier unit testing in CodeGrade, where you will not be needed to go over all of these steps. But for now, just these 4 steps will do as well. So let me check the time. I think I'll not implement this in our assignment, since I think it's straightforward. If you need any help with this, feel free to email us or have a quick look at the webinar with Python, where I do implement this in the assignment. But for now, let me continue with the last couple of advanced things that I wanted to share and leave enough time for the Q&A. So something that we recently published a blog on is grading unit tests. And I know that especially in software development courses, grading unit tests and creating unit tests, first of all, for students is really important. And teachers and instructors needed a way to grade these unit tests automatically as well. So I've dived into that, and I found a really useful tool called JaCoCo, which is Java code coverage. And it's a tool that you can use to auto-grade or manually grade the code coverage of the student unit test that they've uploaded. And the 2 ways you can do this, so manually is by manually looking at the report that it generates. So as you can see down here, it will generate a HTML report, which you can render inside CodeGrade, and it will look like something like this, where you can find all the different Java files that the student has handed in and find the coverage of those files and the tests. Another way is, well, there was a animation there, apparently. Another way is to do this automatically and automatically give a grade to the found code coverage. And for that, I've written a small script, which you can find in this blog and copy from there. But basically, it takes the XML that JaCoCo outputs, and it finds the code coverage in there, and then it simply outputs the code coverage. And as a floating point number, so in the capture point step, then in CodeGrade, you can simply run this script, and then with the default \f, it will parse the final float that you outputted, and that will then be the grade of this capture point step. So if they have 50% of code coverage, they will get a 0.5, so 50% for this step as well. So that makes it really intuitive, since code coverage is just a percentage as well. Great. So let's go over for the next advanced tip, and that is automatically detecting structure. So this is a little bit different than PMD in the use case, where PMD kind of checks if bad structures are present. With semgrep, you can actually check if wished for structures are present, and it gives a lot of flexibility as well. I've written a blog about this and also discussed this in the previous webinar for Python, but this also works for Java. And for instance, the example that I have here, this is something that you may have in a fully auto-graded Introduction to Java course, where you have some theory first on while loops or for loops, and you have a practical after that, in which your students will have to create a simple script where they use a for loop, but they're not allowed to use a while loop. And with semgrep, you can automatically see whether they used the for loop and they did not use a while loop. And in CodeGrade, that looks like this, where you say, well, for loop was used, check. No while loop was used, check. And of course, if they didn't do that, there'll be crosses. And semgrep is really intuitive, as it works with a YAML, where you can simply set up your rules. And we have added a new wrapper around this, which is now in CodeGrade itself. So it's not a pilot anymore, but you can use this inside CodeGrade right away. And we've added the match expected. So this also helps you use this for positive matches. And in this case, this rule above here is for the for loop. So here we are checking if there is a for loop pattern, and we are expecting this, and we set the message and the severity level. And then down here, we check if there is no while loop. So this is the while loop pattern. And we say that there is no match expected here, since that is a bad thing if there's a while loop. And as you can see here, these patterns are pretty intuitive and easy as well. Just note that each language in semgrep has their own patterns. So if you have a Python semgrep YAML, then you have to rewrite that a little bit to make it work with Java. This one is for Java right here, but the one that I use in the blog is for Python, for instance. So how to do this in CodeGrade? You simply upload your tests as a fixture. So that's the YAML file I showed you here. Then you install that using semgrep install, which is now pre-installed in CodeGrade. So you don't have to upload semgrep as a fixture anymore. And then you simply run the unit tests in a unit test tab using the run command from semgrep. And you select the fixtures that you uploaded and the student folder, which you can also just use as a dot, since the student folder is also the current directory. Again, if you want to learn more about this, read our blog, and there is a lot more information about all the ins and outs of semgrep for education. That was everything I wanted to discuss. It was a lot, but I hope that this gave you some inspiration to set up code quality steps for your own assignments, and hopefully also some tools that will help you do that. If you want to have a call with me or someone else from CodeGrade to discuss some of these things in a little bit more detail, or have some questions about it, feel free to reach out to us at support@codegrade.com, and we'll be happy to help you out or think along how you can best do this for your assignments. I'll be stopping the recording right now to go to the Q&A session